Hello everyone, I'm Amay
And I'm Jay.
and today we are going to conduct a product evaluation of the Ubiquiti wireless bridge access point.
Our setup mainly consists of two tripod stands on which we mounted the two Ubiquiti NBE-AC-19 outdoor access points. We used the tripod stands to get elevation, which could help us to provide a clear line of sight. Two laptops, one at the receiver and the other at the server. Apart from that, to connect the laptops to the access points, we use two TP-Link switches. At the two access points were connected over a distance of, that is 0.1 miles. The transmitter side was connected on the first floor of the Heinz Hall, and the receiver side was connected near the end gate of the carrier dome. On both the sides, the access points were connected to the laptops via TP-Link switches. On the receiver side, since we did not have the power, we used IxChariot, which is an enterprise level throughput testing tool to test the throughput between our endpoints. One endpoint was connected to the transmitter, the other was connected to the receiver. We measured bidirectional throughput using round-robin topology, simulating the test using 10 users. Apart from TCP throughput, we also simulated YouTube traffic. Now let us talk about the results. Using TCP high performance throughput in the 20 MHz spectrum, we got throughput of around 63 megabits per second. Increasing the channel bandwidth to 40 MHz almost doubled the throughput, whereas while simulating YouTube traffic, the throughput remains almost constant. We performed 3 iterations for every channel bandwidth. Now let us talk about some of the features of the Air OS, which is the GUI interface of Ubiquiti Access Point. The Air view works as which gives you an idea of the traffic on a certain frequency in the spectrum. The antenna align tool is used to help alignment between the transmitter and the receiving antenna. Using the site survey tool, the Ubiquiti access point scans the surroundings and lists other access points, their SSIDs, their MAC addresses, their encryption types, the noise levels, and the frequency they are working on. The device discovery helps the transmitter to find a receiver. The ping test works as a normal ping from transmitter to receiver to see if there is connectivity. The cable test helps to understand that all the wires and the cables are working well. The speed test is similar to a normal speed test. It measures the throughput between the transmitter and the receiver. Most of the times, the speed test that we measured in IxChariot was similar to the one that we measured in the Air OS. There are 3 modes in which the access point can work. One is the access point point-to-point mode, in which the access point works as a stand-alone access point, just like a normal access point. The station point-to-point is where it works as one transmitter and one receiver, and the station point-to-multipoint mode works like a mesh network where there's one transmitter and multiple receivers.
So Jay, what would you comment on the practical application in the real world for these devices, and would you buy one for yourself?
Sure, Amit. These devices are ideal for remote location and where you don't have the option of running down an Ethernet cable, and it is an expensive thing. For example, you want to have bridge connectivity between 2 branch offices within the same city in a radius of 7 to 8 miles. I think it would be ideal to have these APs forming a bridge connectivity between the offices. Also, since it has the option of point-to-multipoint connectivity, you can connect multiple locations in a mesh topology. And the best part about the device is the cost. It costs less than $100 for one device, which makes it a lucrative deal.
That sounds great, Jay. So anyone out there looking for an inexpensive way to communicate wirelessly, these are the devices you should be looking out for. If you have any doubts, please do write to us in the comment section below and we'll get back to you. Thank you for watching.